In this lesson, we will learn how to establish connection between a Python application and TWS. So I'll go to my project folder and create a new folder where I will store all my code. I'll call this code. I'll go inside this folder, copy the location, and I'll go to Sublime Text, create a new file, and save this file inside our code directory. I'll call this connection.py. Now, if you remember from an earlier lesson, we discussed that IB API has two important classes, eClient and eWrapper, that are responsible for handling any communication between a Python application and TWS. So the very first thing we need to do is import these two classes in our Python application. So first, actually take a look at these two classes inside the source code. So I'll go to the TWS API directory inside C drive and go to source, then go to Python client, and then go to IB API. This is where all the source code for IB API is located. So there are two important files, client.py and wrapper.py, which contain the eClient and eWrapper classes. Let's open each of these files in Sublime Text Editor. Let's also open wrapper.py. So inside client.py, you will see that there is class declaration for eClient, and inside wrapper.py, you have class declaration for eWrapper. So let's go to connection.py and import both these classes. So I'll write from ibapi.client import eClient, and from ibapi.wrapper import eWrapper. So you need to make sure that whenever you build an application that uses TWS API, you need to import both these classes, because these classes are responsible for handling all the communication with TWS. Let's save this file, and let's actually make sure that our script is able to import these classes. So I'll go to my project directory and type cmd to open the command terminal, and then activate the environment for this project. So I'll go to environments, ibapi_env, scripts, and activate. So once this project environment is activated, I'll change the directory to the code directory and run the connection.py file. And as you can see, there is no error, which means that connection.py is able to import eClient and eWrapper. So now that we have imported the eClient and eWrapper classes, the next thing we need to do is create a class and derive it from these two classes. So let's create a new class. Let's call it trading app, and let's derive this from eClient and eWrapper. So once we create this class, all the methods that are available inside eClient and eWrapper become available in this trading app class. So if we go to client.py and take a look at the eClient class, so all the methods that are here, for example, connect method, then disconnect method, isConnected method, all these methods will become available inside the trading app class. And similarly, all the methods inside the eWrapper class, for example, error, connect acknowledgement, market data type, tick price, tick size, all these methods are also available inside the trading app class. So let's define the constructor for this class. So we write def underscore underscore init. We pass in the self argument. And now let's take a look at the constructor for eWrapper class first. So we see that the constructor is blank, so we do not need to specify any init method for the eWrapper class. Whereas if we take a look at the eClient class, its init method takes in self and the wrapper argument. So we'll write eClient dot underscore underscore init, and we pass in the self and wrapper equal to self. Now this might be a bit confusing as to how we can specify wrapper equal to self. And this is because when you derive a class from one or more base classes, then that class is a subtype of each of those classes. So in this case, trading app is a subclass of eClient and eWrapper. So any instance of trading app is also an instance of eClient and eWrapper. And that's why writing wrapper equal to self is correct. So now that we have created our trading app class, let's create an instance of this class. So we type app equal to trading app. So we have the instance app defined here. And next we are going to make use of the connect method, which is available in the eClient class, to send a connection request to TWS. So we write app.connect. And now let's take a look at the input parameters of the connect method. So we go to client and then we search for def connect. So this connect method takes in 3 input parameters. First parameter is the host. This is of type string, and this is the host name or IP address of the machine. Now, since we are running TWS on the local machine and application as well on the same machine, we're going to specify 127.0.0.1 over here. Let's take a look at the next parameter. Next parameter is the port. It is of type integer and it must match the port specified in TWS on configure API socket port field. So let's go to TWS and go to file, global configuration, API settings, and here you can see we have 7497 specified here. So let's copy this, go back to connection.py and specify this value over here. Let's take a look at the last argument, which is the client ID. It is of type integer and it's a number used to identify this client connection. So if you have multiple Python applications running on your system and are trying to connect with the same TWS, then this client ID is used by TWS to distinguish between the Python applications. You can have 32 maximum Python applications running on your system and simultaneously trying to connect with TWS. So this client ID can take a value between 0 and 31. I'll specify the value 0 over here. Now let's see what happens if we run this program. So let's first go to TWS and click on this data tab over here. Let's move this window here. Now you can see here it says API connections listening on port 7497. So TWS is listening for connections from applications on this port 7497. This is what we had specified in the global configurations. Let's go to our command window. And as you can see, I have already activated IBAPI underscore env environment and I am in my codes directory. So let's run the connection.py file and see what happens. So as you can see here, this Python application is now connected to TWS and client ID of the application is 0, which is what we had specified in the program. Now let's go back to the code editor and understand what's actually happening here. So when we send a connection request to TWS using the connect method of eClient class, TWS accepts that connection request and sends back the status of the connection request to our Python application using some messages. But those messages need to be decoded. And to decode those messages, we need to run a function in eClient class. And this function is the run function. So once we run this function, it will decode and interpret the messages that TWS is sending and trigger appropriate methods in the eWrapper class. So in this case, when we send a connection request, TWS will respond back with messages. The run method will decode those messages and trigger the error method in the eWrapper class. And this method right now is logging the status of the connection in a file. And if we want to see the actual messages that TWS is sending back and display those messages in console, we will need to modify this function. We should not modify anything in the source files here, but what we should rather do is modify or override this method in our trading app. So what I'll do is copy this method definition from here and paste it in our trading app class. Let's remove the variable types. And now let's print each of these parameters in the console. So we'll write print and let's say error. Now let's print each of these parameters one by one. So let's print request ID, then error code, and then error string. And one thing we forgot to do is we need to run this method app.run because this is what will decode the messages that are sent back by TWS. So let's save this file and let's open TWS and let's also open the terminal. So as you can see, our application is still connected. So let's disconnect the application first by pressing Ctrl and pause key. And now this is disconnected. Let's again run this application. And as you can see, this application is again connected to TWS. And this time we are getting some output in our console. So this error code of -1 means that this is just a notification and not actually an error. And these messages tell us that TWS was successfully able to connect with a Python application and the data farm connections are also fine.